In this example, we're going to graph a system of inequalities. So step one is to focus on your first graph. So notice our first graph here. What do you notice about this equation here? Well, you should have noticed that with the x squared and the y squared term and a positive number on the right side, that is the graph of a circle. So we have a circle here, and this inequality symbol tells us what type of circle are we going to sketch. Yes, that's correct, a solid circle. Now let's go ahead and identify the center and the radius of the circle. So let's take a look. So for our x, recall that when the x squared term is by itself, that indicates that the x value is 0, and when y squared is by itself, it also indicates that that variable, the y value, is 0 as well. So our center is at 0, 0. And recall, to find our radius, all we have to do is take the square root of this number. The square root of 25 is 5, so our radius is 5. So we have a center at 0 and a radius of 5. So to graph that, recall, all we have to do is to step 1, plot the center, which is located at the point of origin, 0, 0, and then just move 5 units out in each direction. So our circle is going to look like so. Our next step is to determine whether we're going to shade inside the circle or whether we're going to shade outside the circle. So to do that, all we have to do, and by the way, this particular equation is not in that y equals form. It's not solved for y. In other words, y is not isolated, so we can't use the boundary method. But we can use the test point method. And the test point method is a method where you use the test point 0, 0 and plug it in place of the variables, and then you read the inequality statement. If it's a true statement, then you will shade the region where the test point is. If it's a false statement, you will shade the opposite of the test point region. So let's go ahead and plug in our test point 0, 0 using the test point system. So removing the x and replacing it with 0, removing y and replace it with 0. When we do that, all of the left side is simply 0. So when you get it to where you have one number on one side and one on the other, you're going to read the inequality statement. And this statement says that 0 is less than or equal to 25. And that is a true statement because 0 is smaller than 25. So here is our test point area, right at 0, 0. That was our test point. So what that means is, if you get a true, then that means that you will shade the region where the test point is. So that means everything inside is true, which means the opposite, this is the false area, and we do not want to shade the false area. Again, if you use the test point 0, 0, which is the point of origin, if you get a true statement, that means shade everything with that test point, that region. That is your true side. So our circle is going to look like so. Okay, so we're done with the first graph. Next, we're going to move on to our second graph. What do you notice about that second graph? Well, for one, you're correct. It's in the form of slope-intercept form. Y equals, in other words, y is isolated, so we can definitely use the boundary method for that. What else do we notice? We notice that with the inequality symbol of y is greater than, yes, that you're going to be shading the upper when it's time to shade, and that you're going to use a dotted or dashed line because it doesn't have a line underneath it. So let's go ahead and sketch this line, and this is actually a linear equation. So with a linear equation in this slope-intercept form, they're very easy to graph. All you have to do, step one, is plot the y-intercept. We were given a 3 for the y-intercept, and recall that the x value is always 0 for the y-intercept. So step one, plot that point, and then from there you're going to use your slope to rise and run to your next point. And we have a slope of -1/2, which means you can either let the top be negative and the bottom be positive. That's a negative slope. Or you could do the opposite, let the top be positive and let the bottom be negative. Okay, so step one, plot your y-intercept and then rise and run to your next point. In other words, you can fall down 1 and run 2 to the positive side, or you can rise up 1 and run 2 to the negative side, and it'll still take you on the graph. Okay, so let me go ahead and erase my screen, and then we're going to go ahead and proceed with drawing our dashed line there using the slope and the y-intercept. All right, so there's our line. So again, that was to first plot the y-intercept, which is at 0 and up 3. And from that point, we could have fell down 1 and then run 1, 2. You're on the graph. Or from that point, you could have rise up 1 and run 2 to the negative side, and you're still on the graph. So now that we have our graph, now we have to determine, am I going to shade upper region of that red line or lower region of that red line? Well, because it is solved for y, we can use the boundary method. Remember, when you have y is greater than, that means that you're going to shade the upper region. So we can go ahead and proceed with shading that area. And there you have it. We have our graph, but this is not our solution, because remember, when you have systems of inequalities, your solution is the overlapping part. So we want the part where we shaded it blue first, and then on top of that we shaded it red. We just want that overlapping part. So erasing everything else, this is what your graph is going to look like. That is your solution, just that little piece. So keep in mind when you do your homework in my math lab there, that before you click submit to check your answer, make sure you erase the part that is not part of the solution and only keep just the overlapping part. Once you do that, then you click submit and it'll tell you that is correct.